question 5. So, turning points, that is where the gradient is 0, so we have to differentiate this and make that equal to 0. So remember how to differentiate. You multiply by the present power and reduce the power by 1. So 3x squared and minus 6x and minus 9. So that's the differential, but we want the gradient to be equal to 0. So the turning point equals 0, so 3x squared minus 6x minus 9 equals 0. We factorise this. Now notice how all three of these terms are multiples of 3. So I've taken the 3 out to start with, making it a more straightforward quadratic to factorise. So factorising this, we get x plus 1, x minus 3. So our two turning points are when x equals minus 1 and x equals 3. Now we were given that x equals 3, so this is the one that we're interested in, with x being minus 1. Determine whether it is a maximum or a minimum. Well, take a second differential. So take a second differential, so differentiate dy dx gives us 6x minus 6. So at x equals minus 1, this is less than 0, therefore it is a maximum. So it's a maximum. We just need the y coordinate as well, because we were asked for the coordinate, not just the x value. So given that x is minus 1, pop this back into the curve itself to work out what the appropriate y value is. So minus 1 cubed minus 3 lots of minus 1 squared minus 9 lots of minus 1, add 7, gives us 12. So the coordinate minus 1, 12 is a maximum. And this is where we've sketched it. So remember, a positive cubic looks like this. Our maximum is at minus 1. Our minimum will be at 3 over here. And just to be on the safe side, I've also worked out where it crosses the y-axis. This is when x is 0, so when x is 0, the y value is 7.